So up till now, we got an idea of what is minimum spanning tree. Now, next one is algorithmic of. Just before we go to code, we'll understand how the algorithm works. Well, you want to see what a gist about the minimum spanning tree? Check out the video before, or if you want to jump right to the codes, go to the next video. This video is only about algorithms. Okay, so problem description is a spanning tree which might be without a cyclic join, getting not only the spanning tree, the minimum spanning tree is our main motive. A spanning tree of a graph can be defined as graph with minimal set of edges that connects all vertices. Well, a spanning tree can be a distance of connecting any vertices, but a minimum spanning tree is the shortest distance for connecting between two vertices, and as the vertices gets completed, a small spanning tree emerges, which is the minimum spanning tree. So that's what we talk over here, where the weight is computed by adding the weights of all the edges in the spanning tree. In general, what happens is, in general, what happens is the main objective is not only to find the spanning tree, but the minimum spanning tree of a graph. Okay. Now, for this to take place, will consist of some steps. We'll first create a classes for graphs and vertices. So both classes will be defined, in which the steps we'll see. Next, we create a function called mst underscore prime. What this does it takes the graph objects g as an argument. So basically this mst underscore prism just takes g as a parameter, which is the graph object's value. Okay, and then what this ends up doing is it returns the function. Okay, the function will return a graph objects, which is the minimum spanning tree of the graph G. So this mst underscore prime passes graph object G, which ultimately returns in this function the minimum spanning tree. Okay, so in the last video what we checked out, and in this video what we're gonna see, that is how the spanning tree, the minimum spanning tree, comes from the spanning tree graph. Okay, now for this we need at least a main. Consider if this is mst, we need an empty graph type, so we can just keep building on. Step by step to build on. Now this step to step building is called mst, and this is anyway you seen over here, mst underscore prime. Okay, next what happens is an empty graph called mst, like we seen here, is created, which will hold a mst of the graph G. So it's always like step by step, 1 2 3, finding the minimum weight. Okay, now this is like an temp graph for building a spanning tree. Next, what happens is the algorithm works by selecting any one vertex from G and adding it to MST. Now, G is in MST underscore prime. Over here is the full graph. Step by step, one vertex, one vertex, one vertex keeps building on. So the algorithm just works by selecting one vertex from G and adding it to MST. So this is how, like, one by. Now when we talk about vertices being added to MST from G, so from G to MST, like say this is the whole graph. Now which value to take or which value to write, this is calculated over here in the next step. The vertices which is outside MST is nothing but G, that is MST underscore prime functions G, which is outside MST has a neighbor in MST with the smallest distance. Now that MST vertex of the smallest distance is added to MST. Now if there are multiple of the same value, we have a choice to just add one. The next step is the corresponding edge is also added. That is, once it is just identified, it's not done, it is added. So the seventh step is just an illusion. Now eighth step, like the same steps is repeated in a step-by-step way. So wherein the same steps up till now is repeated till all the minimum spanning tree, wherein remember v minus 1 vertices at least, okay, but not v. Okay, so the above two steps are repeated until all the vertices have been added to the graph. And over here we use two dictionaries also. Dictionary is nothing but key value pair. Okay, so those guys who do not know what is a dictionary, it's a small topic in Python wherein the values are stored as key value. Now the use of this dictionary is just for when you call the key value, the value pair comes out. So it can just have, like, say 101 represents some graph type. When you call 101, this comes out. And when designing an algorithm like this, there is always a catch to introduce two dictionaries. That we'll see in the codes, because the nearest neighbor in MST of a vertex outside MST is kept track using a dictionary nearest neighborhood. When we just add from MST underscore prime the G, all the vertices to MST, the nearest neighbor in MST, okay, of a vertex outside MST, that is of these vertices which are completed, okay, these vertices are selected from inside. We should have a track of what values are being added and tracked. Now for this, it's kept only the vertices that's outside MST is kept track of using a dictionary nearest neighborhood method that uses dictionary. So the smallest distance is always stored in a dictionary format. It keeps track of all the records. So just track of this 11 point keeps track of smallest distance.